Welcome to Review and Preview Problems 10-18 to 10-24 in the CCG book. 10-18 says, in circle A below, line segment CF is a diameter and the measure of angle C is 64 degrees. So the first thing that I'm going to do is I'm going to label the measures I know. It asks us to find the measure of angle D, the measure of arc BF, the measure of arc CBF, the measure of angle BAF, and the measure of angle BAC. So the first thing that I know is they told us this was our diameter. So if I look at arc CBF, I know that that has to be 180 degrees. It then asked for the measure of a few other things. It asked for the measure of angle E, the measure of angle D. So when I look at the measure of angle D and the measure of angle E, I notice that both of those angles contain the same endpoints, which is arc BF. They're inscribed angles, so if we find arc BF, we can divide that by 2 in order to get those angles. I also noticed that angle C also has the endpoints at F and B. Therefore, these three angles are congruent. So I know that measure of angle D is 64 degrees. I know the measure of angle E is also 64 degrees. And I know that arc BF is 2 times that angle. So arc BF is 128 degrees. It then asked for angle BAF. So now I'm looking at the central angle right here, which should be the exact same as my arc length. So if I know my arc length of BF is 128 degrees, I know that angle BAF should be 128 degrees. And then it asked for the angle BAC, so because this is my diameter, I can take 180 and subtract 128, and I know that angle BAC is 52 degrees. 10-19 says find the area of a regular polygon with 100 sides and a perimeter of 100. So if I have 100 sides and a perimeter, when I add up all the sides is 100, I know that one side length is 1 unit. I then can take 360, divide that by 100 to get my central angle, which would be 3.6. In order to find my area of my polygon, I need to find the area of that triangle. So if I take 3.6 and divide it by 2, I get 1.8. So to find the height of my triangle, if my angle is 1.8, my opposite side is 0.5, I'm going to use the tangent of 1.8 is equal to the opposite over x. I need to multiply both sides by x, and then in order to get x by itself, I need to divide by the tangent of 1.8, which gives me a height of approximately 15.91. If I take that height, multiply it by my base, divide by 2, I get approximately 7.955, which is 7.96. I have 100 of these triangles in my figure, so 7.96 times 100 would give me an area of approximately 796 units squared. 10-20 says, for each of the geometric relationships represented below, write and solve an equation for the given variable. For parts A and B, assume that C is the center of the circle. Show all your work. So if I know C is my center, I know that each of these pieces represent my radius, so they are in fact equal to one another. I'm going to use inverse operations to solve. So M is equal to 4 for letter A. When I look at letter C, I know that this angle is 3x minus 9. I know that this angle is x plus 4. So this angle should be half of what your central angle is. So if we take our central angle and we multiply that central angle by 2, hold on, the central angle equals my arc. This angle is half of that. So yes, multiply 3x minus 9 by 2, set that equal to x plus 4. So 6x minus 18 equals x plus 4. Inverse operations. We get 5x is equal to 22. Divide by hold on. Excuse me, sorry. Rewind. We got to do that backwards. 2 times x plus 4 is equal to 3x minus 9 because this angle is half of 3x. So in order to set them equal, we need to multiply that angle by 2. Sorry for that mistake. Inverse operations. Let's try this again. 17 equals 1x, so x equals 17. There we go. Letter C. We're working with a right triangle. We know all of our side lengths, so we can use the Pythagorean theorem. So if we take 6 squared and we add that to p minus 2 squared, it should equal p squared. When we do p minus 2, make sure you distribute that out 2 times so you don't lose your center term. 6 squared is 36 plus p squared minus 4p plus 4 equals p squared. Inverse operations, your p squareds are going to cancel one another out. So we have 36 plus 4 minus 4p equals 0. We can move our 4p to the right hand side. 40 divided by 4, p is equal to 10. In our last figure, we know we are working with a 4-sided polygon. So in a 4-sided polygon, I know it equals 360 degrees. There's 2 triangles inside that equal 180 each. So if we set 360 equal to the sum of all of our interior angles, and we combined all of our like terms, we get t, don't confuse them with the plus signs, is equal to 20 degrees. So this all adds up to 18t. So t equals 20 degrees. 10-21 on graph paper plot triangle ABC. If A is at -1, -1, B is at 1, 9, and C is at 7, 5. Then it says find the midpoint of AB. So looking at these ordered pairs, if you notice and draw a slope triangle, you can tell that this rises 10 units and runs 2 units. So the midpoint would be halfway in between that, which would be rising 5 units and running 1 unit. So if we go 5 units up from -1, we know that that is at 4. And if we go over 1 unit, we are at 0. So point D is at the ordered pair 0, 4. We could do the same thing for line segment BC, and we could use slope triangles to find that midpoint. And we would know that that center for BC would be at the ordered pair 4, 7. Again, to go from 1 to 7, you know you go 6 units. 5 to 9 is 4 units. Half of 6 is 3 units over, so 3 units to the right of 1 would be 4. And then down 2 units would be to 7. Find the length of the mid-segment DE. So remember, this is point E, and the point we labeled over here was D. So if we needed to find the length of that, we could use those ordered pairs. So D is at 0, 4. E is at 4, 7. So we know we ran 4 units, and we know we went up 3 units, so we could use the Pythagorean theorem. 3 squared plus 4 squared equals the distance from D to E, which is C squared. 9 plus 16 equals C squared. 25 equals C squared. So the distance of line segment DE is 5 units. Use it to predict the length of AC. So if we are looking at these two triangles, DE should be half of AC, so 2 times 5 should tell me that AC is approximately 10 units long. Now find the length of AC and compare it to your prediction from part B. So if we take AB, if we do 2 squared plus 10 squared, 104, take the square root of that. Then we would take our prediction from part B, which would be 10 units long. 10-22 says ABCDE is a regular pentagon inscribed in circle O. So if we draw ourselves a picture of a pentagon inscribed in circle O, meaning that each of its 5 vertices just touches the circle. So here is our diagram. Then it says, so if we label it A, B, C, D, E, we're talking about circle O. Find the measure of EDC. So these are all radii from the center to the outside. If we take 360, divide that by 5, that tells us that each of our central angles is 72 degrees. If we multiply 72 degrees by 2, it would tell us that the measure of angle E, if those are both 72, these angles would be 180 minus 72, which would give us 108 divided by 2 means each angle would be 54 degrees. So if we wanted the measure of angle EDC, 54 and 54 would be 108 degrees, would be one way to do that. If we wanted to find the measure of BOC, BOC is looking for this central angle, which would be 72 degrees, because that's a central angle. Find the measure of arc EBC. So if we go EBC, we're looking for this whole arc. So this arc is 72, 72, 72 times 3 would tell us that that whole arc is 216 degrees. So remember, you can also look at EDC as an inscribed angle to figure that out as well. Create a map plan. 1023, create a map plan for the following isometric views and find the volume of each. So if we are talking about the front right of figure A, there is nothing in this front corner. There's nothing in this corner, or this corner. So those are all going to be zeros. There is one block here, 2 blocks in the center, 1 block in the right, 2 blocks in the rear, and 3 blocks right here, which gives us a total of 9 units cubed. Looking at our second drawing, if we draw a map plan for this, we have 3 in the back corner, 2, 1, 1, 2, 1, which gives us a volume of 10 units cubed. Did you have to make any assumptions about hidden cubes when you drew the map plan? If so, what assumptions did you make in each case and why? So in both of them, or in this first one, A, we had to assume that there were no cubes in this back corner because we couldn't see anything. We also needed to assume that all of the cubes underneath these levels had things to hold them up. So there were no blocks floating in midair. What other views would you need to see to be sure how many cubes there are? Explain. We would either need to see the left or the back views would reveal if there were any hidden blocks. 10-24. Jill's car tires are spinning at a rate of 120 revolutions per minute. If her car tires radii are each 14 inches, how far does she travel in 5 minutes? So the first thing I would do in this is I would find the distance around my circle. So I'm going to use my circumference. So I would do 2 pi r, which that would be 2 times 14 pi, which equals 28 pi. So in one revolution, the car travels 28 pi inches. So then what we can do is, if we know we travel one revolution 28 pi inches, we want to multiply that by 120 revolutions, which we go 120 revolutions in 1 minute. This equals 1 revolution. We then can multiply that by, we're taking a 5-minute trip, so we get a total of 16,800 pi inches per trip, which would be D.